chemistry, we're going to be exploring more about free radicals, which are actually important in facilitating the growth of various carbon chains or any other organic compounds. And this is going to be crucial first in understanding more about the thermodynamics and more about the kinetics of those reactions. Now, this introduction to this particular particle, or I would say compound, is quite interesting because we do know that the simplest organic radical is called the methyl radical, and you can actually guess what this is. This is actually a methyl group, but in here we just have one hydrogen lost, and we have a radical which is an unpaired electron on this particular carbon. And what do you think this particular geometry of this compound will be? The geometry is actually known to be planar, where we have the hydrogen that are actually in plane with this particular carbon, and they are perpendicular to this particular orbital right here, which is called the sp2 orbital of this particular carbon. Now, this actually comes from the parent molecule, which is an sp3 carbon, which is called methane. Now, focusing on this particular compound, which is the methyl radical, which is what we have right here, how can this be generated? Like we said, we have the parent molecule, which is methane, and what happens is that methane actually is subjected to a particular unknown radical, and what happens is that revealing this particular bonding pair will result in we actually saying that, hey, this particular R group here, which is a radical, comes in and takes a hydrogen atom, and on the other side this lone pair actually stays in this particular carbon. So what happens is that there is a transformation in the geometry of our resulting compound, where we have our hydrogens actually the same plane as the particular carbon atom right there, and we have our unpaired electron, which is actually a radical, and that actually results in the formation of our methyl group or methyl radical. And take note that the other product that is being formed is actually this particular R group with the hydrogen. So what does this imply? This implies that our methyl radical is produced by a process called the hydrogen abstraction from methane, and this is the most common type of reaction that is actually occurred in polymer chemistry. Now, digging really deep into understanding whether any of this reaction is either an exothermic reaction where we have a negative change in the enthalpy, or on the other side we have a positive change in the enthalpy, which is called an endothermic process. We actually dive more into this particular analysis, where we look at the bond that is being broken, where we compare this particular reaction in here at the left side, where we have ethyl radical reacting with a methane, and on the other side, which is the product, we have the formation of ethane and that of our methyl radical, where this is ethane and that is the formation of our methyl radical. So what do we notice here? We notice here that there is the breaking of one bond forming methane right there, and the breaking of the bond is actually in this particular location between this carbon and the hydrogen, and while the formation of a new bond is actually this particular bond right there. So what happens here is that looking deep into this bond that is breaking, we actually notice that the bond dissociation energy of that particular bond is 104 kilocalories per mole, while this bond that is actually formed right here has an bond dissociation energy to be only 100 kilocalories per mole. So what that results in is the change in the energy, which is the change in enthalpy, to be the bond dissociation energy of the bond broken minus the bond dissociation energy of the bond that is being formed. So when you subtract that particular 100 from 104 kilocalories, what we get is positive 4 kilocalories per mole. So what this implies is that we actually have an endothermic reaction, and like we said on our previous videos, most of our bond dissociation energies of any reaction is actually an endothermic process. So that's about it for this particular video. I hope you're able to understand this little bit of the intro. We'll dive more into free radicals in any form of polymer chemistry process. All the same, please hit the comment down below, let me hear your thoughts, share with everyone, and be smart, believe in yourself, and strive for greatness.